Good morning. Welcome to the third semester. So first we are going to see for mathematics, discrete mathematics. I think 2013 regulation, it will be in the third year, fifth semester only conducted. Now it's a 2017 regulation. So it is a third semester paper, second year. So first you should know the subject code MA 8351 discrete mathematics. That it is also useful for your fifth semester also. Some of the topics it will again come in fifth semester. Algebra and number theory will be there in the fifth semester. So most related to your topics. Your subject mostly will be related. So easiest subject, the concept should be hard to understand. So everybody should know the subject code first, MA 8351. And sometimes it is a fifth semester paper also discrete mathematics will be coming the same heading. Subject code only is a differ. So here third semester that is a 8, 3 and 5, 1. Okay, just we are going to the next one. Yeah. So before enter what is the course objectives? What we are going to see this topics. What are the objectives? Once you can, what is the main objectives of this course? Actually, the student section is the logical and mathematical maturity and ability to deal with abstraction. Use counter examples and construct correct and direct and indirect verbs. Introduce most of the basic terminologies used in computer science course and application of ideas in solve practical problems. So unit 1, here we can go the order wise. First you can unit 1 complete, then unit 2, unit 3, unit 4 and unit 5. Here unit 1, logic and proofs. Here the logics already you can study it, I think, AND gate, OR gate, NAND gate. Normally you can write the truth table, true, false, 1, 0. The same things you are going to see the unit 1, the 50% of like that things, and then truth table and without truth table and quantifiers like etc. we can see in the unit 1. And unit 2, combinatorics. That is also some of the topics you can study it in your school level also. Set theory we can study it. So set theory we can write, I think, in a village Tamil newspaper studying peoples, around 45 people are studying, reading the Tamil papers, and 50 are reading the English, 35 are reading the Hindi, like etc. The sum of the same things and permutation and combination, generating function, likes are coming in the unit 2. And unit 3, graphs. Graph like vertex, edge, like etc. That is a graphs will come, isomorphic, like. And unit 4, algebraic structures. That is a in your fifth semester you can study the more in algebraic structures. Here we are going to the group, mainly we can cover. Already you can study in a +2 group, closure property, associative, identity, inverse, like etc. The same things for you are going to see in the unit 4. And the fifth one, lattices and Boolean algebra. So here the lattices we can using, and then Boolean algebra 2 variable we can using like. So these are the 5 units we are going to cover for here. So only for ascending order we are taking the first. You can go for logics and proofs only we are handling for the first things. Okay, what are the objectives? Then what are the course outcomes? So what you can study after complete this unit, what you are studying. So what are the things? All the 5 units. The first unit that describe the logic to solve computer science problems and apply the rules of inference and methods of proof. Second one, apply the proof by mathematical induction and the basic counting techniques to solve combinatorial problems. And third one, apply graph theory model to solve problems of connectivity and constraint satisfaction. Example, scheduling. Project scheduling they are using here. CPM and PERT normally we can say. And fourth unit, define monoid, semi-group, group, normal subgroup, rings, field and homomorphism. And the last one, the knowledge of lattice theory and simplify expression using the properties of Boolean algebra. These are going to see all the 5 units. What are the outcomes we can study? First, you should know what is the outcomes. Okay. What textbook we can follow for here? So here we can using the main most important book, Kenneth Roshan demand. Kenneth Kenneth Roshan. That is a very most important, it's a good book. And Trumply and Monoker. I think Kenneth Goshen available in the net also. Go and the LibGen, you can download it. Otherwise, I can post it in the Google Classroom also. So Kenneth H. Goshen, Trumply, JP and Manohar. These are the two textbooks. Reference book, Gilmody and then scheme publication. That is a lot of problems they are solved. And Koshi, Thomas Koshi, and then T. That is also available. I think Kenneth Goshen, Thomas Koshi, and Gilmody also, the three books are available in online. Just you can check. So I like to follow the Virgajan book also. I like to follow some of the text. I like to take the notes from Virgajan book also. That is also you can do. Local book, whatever you can, no problem. Okay, what are the unit 1? What are the topics is the what we are going to see the unit 1. So unit 1 is heading is logic and proofs. Proofs again logic enna logics we can using. What are the logics? Some very puzzles, a lot of puzzles is there. We can using the logical puzzles. Like in church, logical puzzles. The back end work. Here we are using the AND gate, OR gate, NAND gate, NOR gate, like etc. And aptitude exams also some of the questions asked from the logics. Proofs, proof methods meaning like direct proof, indirect proof, method of induction. These are all you can study. Like some type of proofs is there. What type of proofs? Okay, here what are the subtopics we are going to see? Propositional logic, that is the first one. Our propositional equivalences. So first today we are going to see propositional logic. So propositional equivalences, predicates and quantifiers, nested quantifiers. Quantifiers they can use. Nested quantifiers, rules of inference. What is the inference for all? Directs we can use for here. Introduction to proof, that is a last. These are the things logic. The 5 topics are logic. Then the proof meaning last 2 topics. Introduction to proofs, proof methods and strategy. So propositional logics, that's we are going to the next one. First one. These are the numbers, logics we can using how to solve the puzzles. That's some examples I give. So what is the first definition? We are going to introduction and then what is the first definition? And the introduction is main. Mostly it is using the lot of field. Computer science will be using in the most of the field we can using for the proposition and logics we can using. So first, what is the proposition? What is the definition of proposition? When you can say the given statement. Now statement, another name, declarative sentence. That's proposition. Proposition or statement. A declarative sentence that is either true or false, but not both. So statement is, you can after the statement you can say, yeah, it is a true or false statement. It is a true or false statement, not both. So that is called a declarative sentence. So a declarative sentence that is either true or false, but not both is a proposition, or another name is statement. So which we will denote by the lowercase letters. Normally we can use the proposition as the lowercase letters. Sometimes the question paper like you can using capital letters also. So P, Q, R, S and T. These are the things repeatedly we can use in the terms. PQ normally we can using for 2 variables. For 3 we can use PQRS. PQR 4 meaning S and 5 terms will come T or some other things for our notation. And the variables are PQR or T or Boolean variables or logic variables we can say. Why we can say like that? These variables only existing value true or false, 1 or 0, false na 0, true na 1, true or false or 1 or 0. That's why we can say it's a Boolean variable, only 2 things. But what is the truth value? The truthfulness and falsity of a proposition is called its truth value, denoted by capital T, true, and F for false, respectively. Truth we can write T and false for capital F. These values are often denoted by 1 and 0 by computer science. So normally we can using computer science students 1 and 0 they can using, but here we can use true or false only we can using for here. Some more examples of whether we send a statement is whether it's a statement or not. Statement is not a command. It is not an explanation like etc. For example, the following sentences are propositions. So Washington is the capital of the United States of America. It is a true statement. So yeah, of course, Washington is the capital of the United States of India. United States of America. That is a true. So output is true. So it is a sentence is a proposition. 3 plus 4 equal to 5. Yeah, of course, 3 plus 4 is 7. So it is not equal. But the statement is conformly, we can say it is false. In case, in this variable, x plus 4 equal to 5. For example, non-proposition, not proposition example I will give. X plus 3 equal to 5. For that, x is unknown. X can take any value. We can write x equal to 2 or 8 by 4. Whatever I can write, fraction like. So, upon x is an unknown variable, it is not a unique answer. So, different answers will come for different persons. So, that's why this is the first one. These are the examples for the propositions. And not proposition meaning, let me go, say explanation sentence. X plus 3, x is unknown, close the door is a command. So Kennedy was a great president of the United States. The opinion of the different peoples. We cannot say it is a true or false. So for other side is a false, other side is a true. So we cannot say it's a either or oscillating. So that's why it is not a statement and a statement. So what is my line? So interrogation, like this type of questioning, like this type of things is not a statement. First, you should understood what is the proposition statement. Until that, some of things, 7 wonders are in the world, so 8 wonders in the world. So, like until now, what they have decided that until that it is a true statement. In futures, it will be changed. The proposition will be changes, true or false, like depending upon that. So, at present, what is the command or what is the statement? For example, note the sentence is false. This sentence is false. That is a statement. This sentence is false. Yeah, it is certainly a valid declarative sentence, but it is not a proposition. It's a paradox or self-contradictory. Why? The statement is false. What statement is false? We cannot control the truth value of the proposition. What is the truthfulness? How we can believe the statement? The sentence is false. Which sentence is false? We don't know the previous one. So that's why the truth value of a proposition may not be known for some reasons, but that does not prevent it from being a proposition. So like it is not a proposition. Yeah. And definition of primary statement or simple statement. Normally we can say it's atomic statement. A statement further we cannot split, or sentence we cannot split. There is no other conjunction, no connectives. And or if then my statements that is we can say it is a primary statements. A declarative sentence which cannot be further split up into simple sentences are called primary sentences, or atomic statements, or primitive statements. These are, we cannot split further. Okay, suppose 2 or more simple sentences, if we want to connect, we need some connectives. A and B, Ramu is a good boy and good health, like etc. whatever that things. And the conjunction, that is a connectives that we need. And meaning conjunction, sometimes we can use it. So here the connectives we can use in two or more simple sentences. So connective is an operation which is used to connect 2 or more than 2 statements. It is also called as logical connectives or logical operators. So some more connectives we can using for here, and, or, if, then, biconditional, exclusive or, NAND, NOR, like etc. So, and compound proposition, a statement which contain 1 or more primary statement, that is a simple statement, and some connectives we can use to connect the simple sentences are called compound or molecular or composite statements. For example, let P, Sheila is bright, and Q, Sheila studies every night, be a statement. These two are the statements. Like I would like to use the connectives, disjunction, that is all, we can say the symbol is all, like is a B symbol. P disjunction Q, Sheila is bright or studies every night, or and. If Sheila is bright, that's why he is studying every night. Like whatever we can write if then statement. So thus P disjunction Q, we can read the symbol as disjunction. P disjunction, the operators B disjunction Q is a compound statement. B disjunction Q is a compound statement with primary statement as P and Q and connective as disjunction. That is a V symbol, like it is a disjunction. Yeah. 5 basic connectives. Serial number 1 to 5. Logical connectives. Normally, what is the name of that connectives? What symbol we can using for here? Type of operators, or how many statements we need to connect the connectors, and precedence of logical operators. Not gate. Not gate. Now input is only one for it's enough. So statement, if we can give, I would like to negate the statement. Yomu is a good boy. Yomu is not a good boy. Not. Only one statement is enough. That is the type of operator here, unary. The name of that symbol is negation. Normally we can using the both symbol, negation, tilde symbol, or like upside down of L. Reverse and then upside down of L we can using the symbols. Negation. Most of the papers they can using the both symbols. And authors are using the both also they can using. So both you should know. Normally we can using the first symbol. Normally I am using for here. So negation. It's a unary operation. These are the first preference. First we can do in the entire proposition where bracket is not given. For example, the calculator, if we can without bracket, we can giving the some numbers, how they are calculating, what they can first they are add, addition or division, subtraction. So that is the BODMAS rule. Normally we can say in calculator. Bracket quoted terms they can first do it. And then division, next division, third addition, fourth subtraction, like etc. BODMAS multiplication, addition, subtraction. So first bracket are, second division, then multiplication, addition, subtraction. These are the 5 things. Same like that here. First we can use negation. Next and. Normally we can say logical connectives name is and, but we can pronounce as the symbol is conjunction. Conjunction. The junction like connect pandrenge. So conjunction. The symbol is upside down of V. You have to remember that term, upside down of V. So conjunction. Binary. We need 2 simple statement we need to connect. Minimum 2. So that's why it's a binary. Compulsory 2 statement only we can connect. Is the second preference of this one. Third one, all. All meaning either or, just all, either or. That is normally you can using disjunction. Disjunction. That is also we need 2 simple statements. The third preference is third. Fourth one, if then. Normally we can say it's a conditional. If it is a true, then the output is what? Or implication. That is normally we can say the mathematical statement is implies. Previous steps to next step we can write implies. Already equal to is there, we can write implies. The same simple implies a single line and arrow in the right side. So and then binary and preference is 4. Last one, normally IWF, if and only if normally we can use. Biconditional. That is a binary statement normally we can using. And the preference is 5. Okay. These are the 5 basic operators, and from this what you can using the next one, what is we are using for, what is the truth table of this one, what is the truth table we are going to use for here. Yeah, next one. Once again, let's take that. So step by step we can not gate. The input is suppose the proposition P and Q. Definition of negation. Let P be a proposition. The negation of P denoted by negation P, the symbol is negation, is the statement. The proposition negation B is read as not P or negation P. The truth value of the negation of P is the opposite of the truth value of the P. If P is true, the negation P is false. If P is false, the negation is true. For examples, today is actually, we can write Friday. Actually, today is a Thursday. Upon negation, today is not a Thursday. 5 is greater than 3. It is a true statement. Next, negation meaning 5 is less than 3. It is a false statement. Greater than, then ulta is less than. Equal, not equal. These are the negations. And next we are going to for and conjunction. That is an AND gate. So let P and Q be propositions. The conjunction of P and Q denoted by P conjunction Q. That is the preposition P and Q normally we can write. The conjunction P conjunction Q is true when both P and Q are true and is false otherwise. I think most of the students you can study in your school level also the same things, conjunction. So P and Q, normally we can write any preposition. First we can take it as P, 2 times true, 2 times false. How many inputs we can PQ? So 2 power 2, there are 4 inputs will come up. So 2 true, 2 false. Next to true, false, true, false. This is the order you have to remember. Suppose in case 3 input, 3 statement, simple statement, 2 power 3, 8 output we can write. 4 true. For example, PQ, or if I like to take it as, we can write in the place of P, 4 true, 4 times false. Next to Q, 2 true, 2 false, true, true, false, false, true, true, false, false. And next one, all, true, false, true, false, true, false, true, false. These are the 3. So maximum 3 or 4, rare cases 4, 4 meaning it will become as 16. So maximum they are asking 3. These are the things are truth table. So conjunction meaning either one false in the input, the output is false. Both will be true, then only is a true. All the other cases are false. One of the input is false, the output is false. So today is a Friday, it is rainy day. Conjunction, today is Friday and it is raining day. And disjunction, same. Let P and Q be prepositions. The disjunction of P and Q denoted by P disjunction Q is the preposition P or Q. The disjunction being a false when both input. Disjunction meaning if the both input is false, then only is false, or otherwise one of the input is true, we can say it is a true. Conjunction meaning one of the input is false, output is false. Disjunction meaning one of the input is true, the output is true. That's all. Both input is false, then only it is false. All the other cases are true. Like example, students who have taken a calculus, so computer science can take this class. Like the students have taken a calculus or computer science can take this class, like etc. Conditional, if, then. How to this know for how to remember this formula? If the input is true, the output cannot be false. Suppose the output is false, that is the value is false. Other true, false, only false. All the other cases are true. True, false, only false. If, then. If the statement, that is a P implication Q. If, then, conditional. So ancient or premise, consequence, hypothesis is called the hypothesis. Normally, and antecedents or premises. Normally, we can use the word is premises. Premises is nothing but the hypothesis, premise. Okay, conclusion. A given statement P is given, that is the hypothesis. P is called the hypothesis, the premise, given premise, and the conclusion is Q. Like a conclusion of Q is conclusions or consequence, that is a reverse, like Bahubali conclusions. We can say the conclusion Q. So the example, if I am elected, then I will lower the taxes. If some person is saying, if I am elected, only if he is elected, then I will lower the taxes. The converse is not true. Yeah, if I will lower the taxes, can you elected? That is not possible. If I am elected, then I will lower the taxes. That is a if, then. If the statement is true, then the output is true. If the statement is if I am not elected, then I am not able to lower the taxes. So false, false, and false may be true, like etc. And biconditional, both cases will come. True, false, both of the input is same, then the output is true. Both of the input is same, then the output is true. For conditional, true, false, only false. All the other cases are true. For here, one of the input is different, the output is false. If the both input is same, we can say it is a true. That is a biconditional, if and only if. That is a conditional statement twice. P implies Q and Q implies P. These are the biconditional. P tends to Q and Q tends to P. Both we can check. So true, false is false. The ultava we can write true, false again will come. The statement is true, false also is false. Like that means. Okay. Next one is a biconditional, conditional, biconditional. Okay. Next one. exclusive all, like etc. We can using. Normally we can using the same things. We can using exclusively all. Once again. So there till now we can see for and first one is the negation. Next one is the AND gate, OR gate, and if and only by conditional, by conditional. Now we come back to exclusive OR. Now the plus sign board we can write circle. Plus we can use circle symbol inside the circle plus. P and Q are proposition. The exclusive OR. That is the meaning exclusively. For example, if you can go for evening some hotels. So what type of you drinks? Hot drinks. Okay. Then they are asking coffee or tea. That is exclusively they are asking the questions. So coffee or tea. That is exclusive. Exclusively what you need. So either one, not both coffee and tea. Either one we can say coffee or tea. That is exclusive. That is the things I will give some example. So Bernie will play basketball at 3 p.m. today. So Bernie will go to matinee show at 3 p.m. today. So at the same time, he can go either one. Either if he can go basketball or matinee. So if he went to basketball, he cannot go for matinee. If he go for matinee, he cannot go for basketball. Either one will be true. Not both will be true. Not both the cases not false. Either one compulsory true. Either he go to basketball or matinee. He go either one compulsory. So none of the cases is not possible for here. That's why if both input are true, the output is false. Both input are same, the output is false. One input is true, another input is false, then we can say it's a true. Like ulta, the same for negation of the biconditional we can say. See, the biconditional, both input is same, the output is true. Different input, output is false. The same for name opposite for here. Both input is same, it is false. Different input is true. So negation of the biconditional. So negation of B biconditional Q we can write. That is exclusive all we can write for here. For some example for here, construct the truth table. Negation of P conjunction Q. So first we should find P conjunction Q first. Then you can go for negation. Bracket first, then go for negation. So for P, Q, here only the two input. That's why 2 power 2. 4 outcomes will come. So true, true, false, false, true, false, true, false. That is a P and Q. P conjunction. Conjunction meaning either one false, the output is false. So first statement is true and remaining is false, and negation of P conjunction Q, ulta same. Negate the given input. False, remaining element true. Second, B question. Negation P, disjunction, negation Q. So first to find the negation P, then negation Q, then you can go for disjunction. So similarly, you can write for the other cases, you can solve. For examples, true, false, like etc. We can use the statement for here. Yeah. So try to note down this. Please note down the question now. Try in your home itself. I also will give the answers. Try to check whether the answer is correct or not. So construct the truth table for. Please try to note down. It's always max class. So doing with a notebook and pen, that is will be useful. And sometimes we can go for live classes also. After this introductions, the basic definitions will be given. Then some problems will come. I would like to go on the live session. That's why we can along both we can do. It will be easy. That will be remember also. So most of the first unit will be easy and only for understanding. That's why you can try to note down. So whatever the problems and homeworks and clarify all the doubt. Okay, here. Try to note down the question. Construct the truth table for P tends to Q, conjunction Q tends to P. Answer is, I like to give the column wise. True, first value true, false, false, true. This is I give in this order. P you can take it as true, true, false, false. Q you can take it as true, false, true, false. This is the proper order. Sometimes they are taking some different order, the answer will be different. So both input is true, my output is true. One of the input true, false, output is false. False, true, the output is false. And both input is false, output is true. Can you remember true, false, false? What is the statement of this one? Previous, you can see the connectives. What connectives for this one? True, false, false. That is the both input is same, the output is true. for different input is false. Can you give anyone tell the answer? Unmute and then tell. Can you remember what is using the connectives? OR gate and gate, because two input, not negation not coming. So OR and gate, OR and OR, conditional, biconditional, exclusive OR. Out of this five, which of the output is the here? The answer is true, false, false, true. Can you coincide which? Either and or if then, conditional or biconditional or exclusive OR. Yeah, biconditional, because the both input is both input is same, the output is true. Either one of the input is different, it is false. The same negation is exclusive OR. Similarly, next one, second sum, negation of P conjunction Q biconditional, negation P, disjunction, negation Q. How to do the table? First you can find P conjunction Q. Next you can find negation of P conjunction. Next column for negation P, disjunction, negation. For example, the previous one, only the previous question I like to biconditional I can use it. So I can take the output of the fourth column and the last column. Fourth column, last column, yeah, negation of P conjunction Q and negation P, disjunction. Fourth column, last column, take the biconditional. Biconditional condition is both the input is same, the output is true. Here we can see third and last, fourth and last column both are same. False, false, true, 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 true. So answer is completely true. That we can study the next one. If completely true meaning that is a equal answers. Both the statements are true. That is a tautology we can study. So upcoming definition we can say. So we can tell for tautology. All the statements are false will come, contradiction will come. These are the examples. And for example, some more examples for three variables. Construct the truth table for yes. Yes is the statement. Negation P, conjunction, negation P, disjunction or. Disjunction, bracket, Q conjunction or, disjunction P conjunction or, separate bracket. So here the bracket is must. Order is compulsory. The preference of order is must. So first you can do the bracket. I would like to take it as for my convenience. I like to draw the table. In the heading, there is no other space provided for all the things. That's why I can go for step by step. Previously, I can take it as S1. Some of the book, they can write the 3 lines, concurrent. S1, negation P, disjunction, or I like to take this. I think only connective symbols will come, I can take it as. Don't take negation P as S1. No need of that one. So S1 is negation P, disjunction, or. S2, Q conjunction, or. S3, P conjunction, or. The bracket term, I can take it as S1, S2 and S3. And S4, negation P, conjunction yes. That is the first statement. So first inside bracket, I like to complete it as S1, S2, S3. And then common bracket, first two, negation P, conjunction, negation P, disjunction or. That is a negation P, conjunction S1. That I can take it as S4. Next S5, S2, disjunction, S3. These two things. Other bracket. So final step, so final conclusion of S4 disjunction S5. That is easy for me. So first P, Q, R. There are 3 input. 3 input meaning 2 to the power 3. 8 outcome will come. So that's why I can write 4 true, 4 false. That is a P. Q meaning 2 true, 2 false, 2 true, 2 false. And R, true, false, true, false, true, false, true, false. First I like to identify negation P, then go for S1. S2, try to give the glittered lines. Then only it will be easily. Some of the students are not so ruled paper, it will be okay. Unruled paper, they can write some mismatching. It's not coming as straight mismatching. That's why I can try to put every line. That is easy to locate the value is correct or not. So next one, because you can depending one upon the other. Suppose if you can done one mistakes in S1, it will be reflected in S4. So in the evaluation point of view, we cannot check step by step. We can just go to the last column. Yes, the last column answer we can check it. And also first 3 columns are both all the input are true. The output is true. Yeah, it's correct one. Next true, true, false. Yeah, false. That is we can check only the last column maximum. Some of the faculty members have checked first 3 input and the last. In our input, some students they can write some different ways. If we can write the input is like this order, we can write the output is yes. True, false, and the remaining 4 true will come. So First S1, S2, S3, then S4 go, then you find S5, then finally S. That is a step by step you can do, it will be easy. These are the examples. Like another one is a well-formed formulas. WFF normally we can say. Well-formed formulas, the same definition little bit you can know. A statement formula is an expression which is a string consisting of variables capital letter with or without subscripts, C1, C2, without subscripts, parentheses and connective symbols. Not every string of this symbol is a formula. We shall now give a recursive definition of a statement formula, often called a well-formed formula. Well-ordered set sometimes we can study. For example, functions also we can study well-defined function. So that is whether it is a function or not checking. That is called a well-defined function. Same like that we can check well-ordered formula. That is a well-formed formula. The rules of well-formed formulas. A statement variable standing alone is a well-formed formula. If A is a WFF, then negation A is a WFF. Both. If A and B are WFF, then all the connectives also is WFF. A string of symbols containing the statement variable, connectives and parentheses is a WFF. If and only if it can be obtained by finitely many applications of the rules 1, 2, and 3, like etc. Already I told it. Tautology. So a statement formula which is true. A statement formula which is true regardless of the truth value of the statement which replaces the variable in it is called a universally valid formula. Normally we can write equivalent formulas we can say. Tautology meaning both the statements are true. X equal to y. Instead of x I can take it as y, or instead of y I can take it as x. That is called the statement. So that is a statement is replaced variable. It is a universally it is followed. There is a whatever any one you can check the answer is correct. Both are same. So that is a universally valid formula or tautology or logical truth. For example, definition. So contradiction, a statement formula which is false regardless of the truth value of the statements which replace the variables in it is called a contradiction. So it is not equal statement, that's why you can take it as a contradiction. That is, for example, you can check in the truth table, the output column, that is the last column as the output column. If we can consider the last column, all the answer is true will come. We can say it is a tautology. Last column completely it is true, false will come. It is a contradiction. Okay, this is easily you can identify. Now note the negation of the contradiction is tautology because last column all the things are true, false. We can take the negation. It is a true come. Yeah, log the. Yeah, any doubt? I think unlock your mic. Any doubt, ma?
No, yeah. Sir.
Yeah, okay. And contingency, next one is a statement formula which is neither tautology nor contradiction or contingency. That is a true false mixingly will come. This is a contingency normally we can say. For example, is the formula Q disjunction P conjunction negation Q disjunction negation P conjunction negation is a tautology. Show that sometimes say yeah, check whether it is a tautology or not. So take it as for example directly I can write. Otherwise you can take it as S1 as P conjunction negation Q, S2 as negation P conjunction negation Q, and then S3 Q disjunction P conjunction negation Q, like etc. Whatever you can write. Or S1, S2, S3 simultaneously you can write disjunction. For example, the last column, 3, 4. Sometimes some book they can written the heading is 1, 2, 3 will given. Q as 1, P as 1, Q as 2, negation P as 3, negation Q as 4, P conjunction negation Q as 5, negation P conjunction negation Q 6, and the last one is 7. Here 4 disjunction, 5 disjunction, 6. All the 3 you can simultaneously you can using for disjunction. What is a disjunction? Either one true, the output will be true. So you can check 3, 4, 5, 6 columns. Any one of the value true, you can write true. Yeah, any one of the value. Negation of P conjunction. Same like this. Second 5, 6 mark. In a Q then second 5, 6 column you can take it as.
Sir,
either one true.
Minutes, sir.
Yeah.
10 15 minutes.
No, 2 minutes.
Have the break.
No problem. Yeah. So this is the tautology. Yeah. Like example of tautology, this is the contradiction. Lost things, all the statements are contradiction. Okay, up to this you can know. This is the first class I like to for logical weapons. Next class we can go for logical equivalences. So here also I will give the two homeworks. These things already the same things I can set off the PDF. I can put it in the Google Classroom. Please download and the homework problems you can try to this. Two homeworks already given and also this. So try to do the homework problem, okay, and then check your answers. I think the homework problem is the first one is a tautology. I can check. First one is a maybe tautology. Second one is a tautology. That's why I can write the statement as true. So you can check and any doubt you can ask now. Students, if you have any other doubt, almost time is up. Is there any other doubt, ma'am? Hello?
No, sir.
Yeah.
So this is the interactive session only. So you can ask whether it's right or wrong. Just to interact. We don't know whether you are listening or not. So for that purpose also, please, you have some questions or interact stops. Thank you.
Okay, ma'am. Thank you, ma'am. Okay. Okay, thank you. Next section.
Recording minutes sir, recording close
பண்ணிக்கோங்க. Ma'am. That was
சரி.
I can check.
Okay.